Welcome everybody to this. It's the next to last talk that we have at SBA Life Academy. Today we have a very special guest, Julien Vehent, who is operations security guy at Mozilla. So he's working in operations security with Firefox. Everybody uses products probably every day, where Julien is one of the responsible persons and in charge of the secure operations behind it. So we are very happy to have you with us today, Julien.
Thank you. Good morning.
The stage is yours, please.
Thank you. Hi, everybody. Thanks for tuning in. So I'm happy to be here. This is actually the first Zoom conference that I give, so we'll see how that goes. But I have the Q&A open, so I can see questions as you ask them. Otherwise, I'll take some time at the end to answer all of your questions. So as Thomas said, I run the operations security team of Firefox, and that means we protect all of the backend services of the Firefox browser. So there's a ton of APIs and backend services that are tied to the browser that help it, run security and manage accounts and synchronize between systems and protect you from bad websites and et cetera, and we run all of that infrastructure in the cloud. So my team's job is essentially to keep that environment secure and keep the data that you share with Firefox secure. And I joined that team. I joined Mozilla 7 years ago, and I joined the cloud team about 5 years ago. And I've been building kind of like security culture inside that group since then. So I am a French security engineer. I grew up in Normandy. I moved to the US about 10 years ago. And I'm now in Florida, where it is nice and warm already, a little too much, I think. And I have been essentially working in the space of web services for the past 2 decades, and in cloud services since the early 2010s, mostly with AWS at first. I've been interested in DevOps and et cetera. And in 2005, 2006, I started writing a book called Securing DevOps that essentially explains how we designed the security infrastructure of Firefox services, mostly in AWS, but that's also applicable to other environments. And that book was released in 2018. So a lot of what I'm going to talk today is explaining further details in the book, but the part that isn't really discussed in the book is the cultural aspect of this. So here I wanted to share some of the cultural bits and the way we approach that security culture inside the organization, so you can maybe use it in your organization and help grow your security culture as well. So this story starts last year, around summer of last year, when we're reviewing our security investments within the team, and we're looking at where we spend our time and resources. And one thing that became interesting is that we were heavily invested in security services, essentially building, designing, operating security services like the Firefox signing service or fraud detection pipeline, really engineering. And we're spending very, very little time on infrastructure and application security. My boss was reviewing this with us and asked, like, is that okay? Is that the right kind of investment? It certainly looks kind of strange for an operations security team to be spending so little time on infrastructure security. So I took a bit of a step back and started looking through our data and our security metrics and try to understand exactly how we were doing and where we were at to answer that question, to see if we were actually able to de-invest in infrastructure and application security. And what became apparent through the metrics is that, yes, in fact, we're doing really, really well on the infrastructure and application security metrics. Most of our AWS accounts were in a very good state. Adoption of our application security controls was good. So we could really start shifting resources away from what we had 3 years ago, which is here, really spending over half of our time on infrastructure and application security. Actually, if you put the two together, it's about 80%, which is really right. And very little time on engineering new services. And we could shift that to actually engineering the future and spending a lot less time on the baseline core infrastructure and base application. So what I want to talk about is a little bit of how we got to that point and what we did to get to that point. Because obviously, if you're building a security team, what you want is for them to spend more time engineering better solution and less time firefighting, essentially, and doing incident response. And that's where we're at. So I have probably enough data at this point to reflect on how we got there. So we started this DevSecOps. I don't really like the term, but let's call it that. Around 2015. And that was an interesting time for me because I'm really not an early adopter of anything. What I'm learning these days is woodworking and joinery. That tells you how much on the bleeding edge I like to be. But anyways, in 2015, we started looking into how to do this new fancy DevSecOps thing. And I was always super interested in ways to host services efficiently. And I had a lot of experience also as a system administrator in AWS. And I kind of wanted to apply that to security because the ways we were applying our security controls in the infrastructure didn't make a whole lot of sense to me. So the cloud services group of Firefox was started a little bit before that time, and they were looking for a security engineer. And they asked me, do you want to join our group and help us build the security muscle inside that group? And that was super interesting to me to be able to join a greenfield and essentially build the security infrastructure from scratch. But as a security engineer, you were often tempted to approach joining a new team a little bit like this. Behold the security engineer, the might of the security expert who is going to join a team and tell everyone how to do things properly. But in this group, this would have been a little bit like joining the lion's den, essentially, where the systems engineers, the operations engineer would not have let this fly at all and would probably have torn me apart into small pieces if I had started playing the arrogant French guy trying to teach them how to do security. So I knew I had to find a different approach to win them over and win their trust. And thankfully, quote unquote, a colleague and good friend of mine who works in that team as a systems engineer made a mistake early on. And something that happens to really everyone at some point, he made a commit that was overly broad and pushed that to a GitHub private repository, thankfully, not a public one. And that commit contained all of the clear text secrets of the infrastructure, all of the configuration secret that was stored in a separate repository, but the sub repo essentially got committed into the main provisioning repo. So that was a fuck up, a good wake up call for the entire team. And since I had just joined, they said, well, that looks like a security problem. Why don't you go and fix it? And to me, super interesting, secrets management, maybe a bit of cryptography in there. Let's go and fix it. That's going to be fun. And the way I approached this was actually very different from what I would normally do. At the time, at least. What I would normally do at the time was pick the best solution for the problem, the best security solution for the problem, and force it onto the operations team. You got to change your practices and use this tool because it's the right tool for the job. Instead, what happened here is that we started evaluating how the tool should behave with the operations team. We started discussing together what the customers needed, essentially, and looking at the provisioning infrastructure, how we had to distribute those secrets to the EC2 instances that were auto-scaling and how decryption should happen, et cetera, et cetera. And by the way, this is an open source tool called SOPs. You can go find it at github.com/Mozilla/SOPs to find the end result. We've been using it for 5 years now. And so the first iteration of this was really heavily reliant on a tool called Blackbox. Seems nice wrapper on top of GNU-PG that could do the things, and we could use S3 buckets to store encrypted secrets, et cetera, et cetera. Started looking at ways to improve on that, realized AWS has this KMS service, so we don't have to manage keys anymore, we can use permissions. And then the operations team had some requirements, and they really wanted to have an editor of YAML file, and they wanted history, and they wanted merge commits, and they wanted all of that fun stuff that was just not possible with encrypted blobs of files. So we started adding those requirements in there and ended up with this fourth solution of a KMS-based YAML editor that we could use to control encrypted files and push them into Git repositories that would get checked out into the instances decrypted on the fly, et cetera, et cetera. Very nice solution, a little bit more complex. But at that point, the ops team really wanted this. Now, I only had one problem, is that I didn't know if I could build it. I had designed this thing, and it wasn't entirely clear whether I had the chops to design that. So thankfully, at that point, I had enough buy-in that the engineering team was willing to help build it. And that was really a game changer for me, because I wasn't just a security engineer trying to fix a problem anymore. I was doing it with the help of my organization, the operations engineer, some software engineers who wanted to help. And we built this in actually a few weeks and started using it very, very quickly. So what a point I want to make here is that the first cultural bit that is very important as security engineers is that we don't just build security tools. We build operational tools that do things securely. The fact that they do things securely is almost just one of the many properties of the tool. The main point is that we help the organization run better operations. And when we do that, we add security to it. The second part that I think is very, very important and a game changer for me is that I was no longer an external security engineer coming in to help a team. I was directly embedded inside of that team. I was a member of the operations group. I was reporting to the same manager, and I was really working with them on every issue. If they were working all weekend on a problem, I was helping them all weekend on a problem. When we were doing work weeks and working on things on the future of the infrastructure, I was in that room talking to the same people about what we could add from a security perspective. I was really embedded, sharing the weight, sharing the successes, sharing the failures, and essentially a member of the team, right? And that's a big, big difference from a lot of security organizations. And I think that's a strong factor of success for us, is that we're so closely embedded to the people that do the work. There are typically two organizational models for security teams. The standard one is the central model that we've all seen in every organization. You have a chief security that reports to the steering committee, either the CEO or more likely like the chief legal, chief finance, or CIO, chief IT, right? So it's generally not someone who's directly under the CEO, but pretty close to the CEO. And that chief security will have an entire security organization underneath them, with entire security teams and big budget, right? Lots of political power, lots of budgeting power. They can buy big things, they can run big projects. The second model, and the one that's closer to what we have at Mozilla, is a distributed model, where we have close to the C-suite and the steering committee, more of a strategic chief security. That's more of an advisory type role that really targets strategic risks and helps the steering committee identify and prioritize risks, and then make sure that the security teams that are distributed in the engineering organizations are addressing those risks. The reporting chain is different here, because the security teams are essentially directly attached to the product groups, right? They will report to an engineering director, et cetera, et cetera. So the benefit of that model is effectively that your security teams are much, much, much closer to where things actually happen, where in the centralized model, they're further away. The downside of the distributed model, obviously, is that you have scattered security teams, and in an organization that's very political, they have a lot less influence. So both models are valid, have their pros and cons. I'm not trying to promote one over the other. I'm trying to essentially identify which ones work best for the organization that we have. And at Mozilla right now, it's closer to the distributed model with a twist. There is a third model that I like, which is really the embedding model here, which is essentially having, regardless of the shape of your organization, you need to have your security people very, very close to your engineers. And at some point, like when I started at Mozilla in the cloud services division, I was just one security engineer in one operations group, and it was fine because I was the size of that scope. But nowadays, it's a team of 9 people that's covering a scope of 100 services and helping maybe 300 engineers. And we're not directly embedded, like reporting into every team anymore. So we have to embed ourselves into those teams somehow. And the way we do this is essentially by having dedicated members of the team be attached to development or operations groups. And they're embedded in the sense that if the manager of those engineering groups need something from security, they will go to that security person that's embedded into their team. They will have influence, strong influence over the priorities that the security engineers work on, and they will have essentially a direct line to address problems. On the other hand, the security engineers get direct access to information. and they don't have to essentially guess what's happening into those groups. They can just get it directly from the teams. This works both ways. So you have security engineers embedding into engineering groups. That's great. You also need to allow your engineers to access your security teams. And that's typically what we call security champions. But I think it goes further than that. What I like to call it these days is really running an open security organization, which is really allowing every member of the organization to access the knowledge and the metrics and the concerns and the risks and register and all that stuff of the security team. If I'm a developer in one part of the org and I want to know what the security team is most concerned about, I should be able to access that information very easily. The security team is not a black box. If we want security to spread to the organization, we need to run open organizations. So invite security champions into your groups, run outreach exercises where you get people to essentially ask questions and tap into the security culture as much as they want, and essentially open up as much as you can. This allows you to prevent, I think, one of the main causes of vulnerability, which is people making assumptions. Now, assumptions lead to vulnerability, always. As soon as you're making an assumption about the security posture of your organization, you're opening up a vulnerability because that assumption is most likely wrong. Even if you're mostly right, you're probably just slightly off the mark enough that there's a gap there that an attacker could exploit. I'll give you an example. Last year, all of the add-ons in Firefox blew up. They stopped working almost exactly a year ago. I think it was at the beginning of May. And this is because I made an assumption that proved to be wrong. At the time, or actually 2 years before that, I made the assumption that the verification of Firefox add-ons would ignore the expiration of certificate, because that's how other application signing systems work, right? In Authenticode, certificate expiration doesn't matter if you have a timestamp. And also because of discussions with security engineers in the team. It turned out that this was only slightly true. It was only true for identities and not for intermediate. When the intermediate expired, everything blew up. Assumption led to vulnerability and a fun weekend of firefighting with a bunch of my colleagues who were a little bit mad at me. How do you combat that? Essentially, you have to trust your data. You have to have really, really good data, and not just high-level data, but actually down to the wire data about how you're doing across the board. This is an example of some of the metrics we collect. HSTS adoption on production website. I think this is a little bit, right, that's from a year ago. I should have updated those slides. We're closer to like 87% of HSTS adoption across production websites. And the ones that aren't compliant is because there are CDNs or environments where we can't really set HSTS. GitHub branch protection. This is just a sample of some of the metrics that we have. The point here is that you need to have really, really good data so you don't have to make the assumptions. How do you get that data? You need to have really good tests. Those tests, a lot of vendors will tell you they have solutions to build tests and increase visibility. You have to build your own because tests heavily depend on how your organization behave. What we did here, and that's a framework called Frost, you can find it at github.com, Mozilla Frost, is essentially take a Python PyTest framework and use that to run unit tests against our AWS, GCP, Heroku, GitHub environments. And those tests have been, some of them are standard, right? Some of them are like, make sure you don't have any databases with public IPs or these sort of things that are really standard to the industry. But some of them, like the one displayed here, are very specific to how we do things. And I want to talk about this for a second. This test allows us to find out which EC2 instances are running on acceptable AMIs, so Amazon images. Effectively, we're finding non-acceptable images being used on production instances. The definition of acceptable is interesting. And at first it was called something different, and we went back to acceptable because we realized that the security definition of acceptable we had come up with didn't match at all what the operations team thought was acceptable. And that was an interesting process for us. So essentially we came up with we made a bunch of assumptions and we designed a system around it. We went to the operations team saying, hey, you have a bunch of insecure systems. And they looked at it and said, those are not actually insecure. Your test is wrong. That's not how we think about those things. And we started having a conversation about this and find out that, you know, there was a notion of where the AMI was hosted and owned. There was a notion of freshness of the updates, et cetera, et cetera. And through the discussion, we essentially refined our test and rewrote our testing logic to match both the security requirements and the operational requirements, and ended up with this definition of acceptable AMI. Now, what the definition is actually irrelevant here. The point is that we defined it together. And then the next time we run those tests, the next time we came up with that graph of what is acceptable and what isn't, we essentially already had full buy-in of the operations team because they had helped us define that state. And we actually have been using that definition for a couple of years now. And the operations manager use it to track instances that need to be replaced or refreshed or services that need to be updated. That's how we gained adoption from it. You need to have tests you really trust that produce good data. The next step is you need to set the expectations. The last thing anyone wants is to be surprised by security requirements at the end of a project. Never, ever do this. It just pisses off everyone and you don't get anything done. How do you set the expectations? Well, you essentially have to tell them very early on what you want the security controls to be and to look like, and give them ways to test. A few years ago, Julien Vehent, who is the lead of the OWASP ZAP project and works with me in the team, came up with this security baseline scanning framework that essentially uses ZAP to run a lightweight scan of a web application. And it tells directly to the developers that what is missing on the application. Is a CSP missing? Is there a content type option header missing, et cetera, et cetera. The way we had originally designed this together, that I also describe in the book, is to instrument the ZAP baseline scan in continuous integration. So here I think it's a Circle CI configuration file sample. And you can see there's a Docker run of the application itself, and then a Docker run of the scanner, and it outputs what at the bottom in the black and green section, which is essentially 2 warnings on the application. Turns out this didn't work so well. The problem we had with this is that instrumenting a complex web applications in CI isn't always possible, and certainly not easy. So each application will run differently. Some will need cloud resources to run, some will need multiple containers to run, et cetera, et cetera. So being able to just boot up a web application in CI to run a scan against it, not super easy. Instead, what really worked for us is running daily scans of staging sites and production sites from Jenkins. That worked really well, and that's what produces our metrics. Another thing that worked really well is checklists. And we grew our checklist. You can find it at github.com, Mozilla-services/websec-check. And we have started using checklists maybe 4 years ago. And we grew it over time. It's fairly long. It covers everything from like infrastructure to application security to some of the business logic trap we want people to avoid, requirements on authentication, logging, et cetera, et cetera. There's a lot in there. And we give that to the developers super early on. As soon as we get to talk to them about their new project, we tell them, here's our checklist. While you're engineering this, make sure that you're following these steps. We also tell them that a lot of the checklist is covered automatically if you host your application in the standard infrastructure, what we call the paved road, right? So if you decide to just spin up a separate hosting environment because, you know, shadow IT and whatnot, you would have to essentially replicate everything that's in the checklist. Whereas here we see the infrastructure portion of the checklist, and it's much longer if you go on the GitHub. All of that infrastructure section is done automatically by the ops team when they onboard a new application, all of the HTTPS, HSTS, TLS management, logging, et cetera, et cetera, et cetera. And that's a selling point to developers to essentially use the standard infrastructure because it saves them a lot of work. And we want to make that visible in the checklist to kind of incentivize them to not go and do their own thing. The other thing that we started to notice is that those checklists are great for project and product managers. They start tracking them, they add them to their production readiness checklist. They say, you know, the security checklist must be completed before we launch. And they start actually telling the devs, hey, have you gone through the checklist? Oh, we still have to do this. We need to give it a couple of days to get through it before we launch, et cetera, et cetera. So absolutely great tool for your organization. Absolutely make your own. Ours is probably a good example, but it's probably also not usable by your organization because every organization is different. And the last thing that is extremely important is to give people self-service assessment tools. Let people test their own application, their own infrastructure by themselves. Don't have them ask the security team every time they need something. It's going to frustrate them. It's probably going to frustrate you too. Instead, give them self-service assessment tools. So this is observatory.mozilla.org that April King and others have built over the last few years. And what's great about it is that everybody wants an A+. Nobody wants to launch a new service that doesn't get a perfect A+. They have that, you know, this is new and shiny and everything should be nicely prepared for launch. And getting the A+ on the observatory is one of the check mark on essentially their readiness checklist. And it has really worked well for us. Every single service that we've launched in the last few years has launched with an A+. That means it has a content security policy. That means it has HSTS. That means it has all of these things that usually take time for us to chase down. So to summarize for this section, clear expectation, checklists, self-assessment tools is how you really get adoption on your security controls. Now, the last thing I want to talk about today is something that is, to me, increasingly important to building a strong security culture. And as I reflect on what we've done over the last few years, I think probably one of the most important aspects of our program. And it's not just not having to say no, but that's a big part of this. What I found is that I came from a culture where the security team was saying no all the time. In fact, I started my career in banks. And in banks, the security team could essentially make or break a project by just attending one meeting and saying, no, you can't do this. And the culture was terrible, essentially. People were changing sides when they were crossing us in the hallway because they didn't want to talk to security and they didn't want security to look at their project. This is obviously not good for security and it's not what we want. What I found over the years is that it is not necessarily the security team's business to tell the rest of the organization not to take risks. It is the security team's business to tell the organization how to take risks properly, which risks are worth taking, and at least helping them understand those risks and quantify them properly. There's a woman I really admire. Her name is Grace Hopper. She essentially designed the first compilers. She was in the army for probably 50 or 60 years. And she used to say something that I think resonates really well with this, is that ships are safe in harbor, but that's not what ships are for. And as security teams, we tend to do this a lot. It's like, hey, don't take the server outside too much. We don't want it to get a cold. So the way we do this internally is that we use a framework called the rapid risk assessment. And the goal of the rapid risk assessment is to have a conversation about security, about threat models, about what can happen to an application, how can it be misused, how can it be abused, and what controls should be put in place. It's a very, very short exercise. It's usually 30 minutes to 1 hour. It is driven by a member of the security team, and we invite the developers, the operations, the product managers to attend. And the goal is really to first have a detailed description of what the service or the application is doing, what are the business goals, who are the customers, what technology is it going to be using, et cetera, et cetera. And then in the second part of the exercise, we collect the data dictionary to understand what data are being manipulated by the service, and we start identifying threats. We organize this around confidentiality, integrity, availability, but it's really more about asking, how can you break this thing? How can you abuse this service? What happens if the database leaks on Twitter, et cetera, et cetera? And what's interesting here is that as security professionals, we're often driven to tell people what could happen and to force them to understand the threats. What I prefer to do with this kind of exercise is to let them discover the threats. So this is more of a question-driven exercise. How would you, for example, that's a question we ask, how would you yourself abuse a service? What would you do to make it do something it's not supposed to do or to harm its users? And you can see the wheels turning in the engineers' heads as they think through these things. And oftentimes what we end up with is, well, a set of recommendations on what to do to make the service more secure, but also the engineers themselves changing the design to reduce the risks. And that's an outcome that is fantastic for us because it's not necessarily security enforcing, it's more security helping the organization think about risks and change its decision-making when they have that information taken into account. So what I think can leave you with today is essentially, if you want to go beyond your security team, not just be a security team, but actually grow a security culture in your organization, you get your security teams closer to your organization, more embedded, more culturally present, more involved with the design, talk to people more, use your tools and design your tools with the rest of your teams. And this is how you essentially dramatically improve the security posture of your organization. And thank you very much.
Thank you, Julien, for this awesome talk and for sharing your experience with us. I think what you're saying is pure gold. I can only highlight everything you say. I've been working in software security since 10 years, and these things are really what matter. So one of the key takeaways for myself is everybody wants to get an A+. So when you give them self-service tools and they can assess themselves, they're not going to be happy with a B or A-. They want to be better. So that's really something that works also from my experience. Right. I have a couple of questions from the audience. There's one question from Matthias. How does SOPs compare with HashiCorp Vault?
We actually use both. We use Vault in some parts of the organization. It's a great tool. Vault is a great tool if you're managing servers in data centers where you don't have that layer of infrastructure management that AWS or GCP provides, but you essentially have to build it yourself. So Vault does great at that. Vault does great in the cloud too, but essentially AWS gives you most of the pieces you need to do this without an external service. So KMS and role-based permissions and all that stuff allows you to distribute your secrets without relying on a centralized service like Vault. The downside of Vault, and the reason why we don't use it where we can avoid it, is essentially it is a centralized service that has all of your secrets. So it's a perfect target for an attacker. And it's also a point of failure. If it goes down, you cannot auto-scale or provision new instances. So the operations team didn't really want a new centralized. We came from the years of running Puppet Masters, and they would go down all the time, and it was a pain. And security team didn't really want to have a central point of you steal one chunk of memory and you have all the secrets of the organization. That's kind of how they compare. SOPs is an editor, and you distribute your secrets using some external mechanism. We use S3 buckets. Vault is a hosted service.
Mm-hmm. Okay, the next question is with regards to what you call a security champion. What's a good skill set of a security champion? Do they have to be more engineering focused or more security focused, or is there anything else non-technical to consider in the skill set of a security champion?
They have to care. That's the main thing. It doesn't matter how skilled they are. There's no notion of a security champion should be an engineer with 30 years of experience. I think in my experience, a lot of junior engineers make great security champions because they still have that passion of the use. And I've seen many junior engineers actually change their organization because they brought in new technologies they cared about. So passion and care is very important. Meticulousness is another one. We find a lot of security champions that are really good at their job. They pay attention to the details, right? You don't want any engineers. I mean, any successful engineer has to essentially pay attention to the details. Sloppiness leads to bad code, leads to vulnerability. So two traits that I would really value. since we're close to intern season, and I hope everyone is able to take interns, even though maybe remotely. I mean, we're doing remote internships, and I hope other organizations can too. I find that interns actually make great security champions because they're so passionate, because they want to adopt the new shiny security things, and they're not afraid of telling their peers that their old crafty technology is actually insecure. There are much better solutions out there. So I think, yeah, passion is probably one of the most important traits.
Okay. So next question, also from Matthias. He says it's only marginally related to the talk, but he recently tried to check a .NET classic framework, not core, application on Windows for outdated NuGet packages with known CVEs. He tried OWASP dependency check and NuGet Defender. Both of them failed. They didn't find anything. Are you aware of any tool that works in that specific setting?
No, I don't have recommendations for tools that would really help with .NET. We are fighting this battle on Node.js or the NPM world, Python pip, a little bit of Rust Cargo, and Go, Java as well. The supply chain is a mess. It is a mess because there is tremendous value in using external dependencies, but the cost is not visible to engineering leadership ever until it is too late. And that's the main issue with the situation we have right now, is that you would end up with mission critical applications that pull in thousands of external dependencies managed by people you've never heard of. You don't even know who they are, or if they have, you know, the right programming skills. They just ship code that gets embedded 3 or 4 layers down of your own dependencies and shipped and runs in the same namespace as the rest of your application. What I can say though is that as an industry, we are all heavily looking into this right now. A lot of projects. So OWASP dependency check is one of them. There are many, like Snyk is a commercial company, GitHub, Microsoft bought GitHub, that bought Dependabot, and so that gets embedded into GitHub now. We are building something similar to audit, to actually look more into trust levels for packages. There's certainly going to be, over the next 5 years, a lot of interesting security tools that try to tap into various package manager databases to identify vulnerable packages. I can't tell what's going to come out of that yet. I certainly don't see an interest from the devs from reducing the number of dependencies they use. So I think it's more our job to help them pick the good ones and identify the bad ones, and maybe tell them when they're really using something that hasn't been updated in 5 years that they should probably look at replacement.
So you showed us during your talk, there was a screen with lots of metrics. You showed the HSDS header. My question, what's Mozilla's approach to systems and service inventory? I imagine you have a huge set of services and systems out there. I'm asking this because I suppose that it's the base for good metrics collection as well, isn't it?
Yes, it is. So my first project at Mozilla was called Mozilla Investigator. It was an endpoint security platform that we built to audit endpoints. And at the time, we're running most of our infrastructure in data centers. And Mozilla Investigator was supposed to be fancy threat hunting, go find malware, et cetera, et cetera. Never found any malware, but we used it heavily as an inventory tool. Essentially, running an agent on every server is a great way to figure out, you know, what they're running and build an asset database. Nowadays, we don't run that at all anymore. We rely on the infrastructure management layer of the cloud provider. So AWS lets you essentially run describe instance on every single production instance you have. GCP, Azure, Heroku, all the same. What we have in our asset management really inventory is more of a thin layer that ties tags and labels to services. And so we will know that everything that's tagged this way will map to the Firefox account service. And we have, it's basically a bunch of CSV files in a GitHub repo. It's not very long. It doesn't need to be updated very often. But then we have scripts that essentially every day will use that the database, right, of mapping between labels and services, and will go retrieve all of the information directly from the cloud providers and put that into our metrics. So we don't maintain a separate asset management database. We just have a layer of glue between some service mapping tables and the infrastructure management layer.
Mm-hmm. I also have two questions regarding dynamic application security testing. You mentioned that you're using OWASP ZAP for that purpose. Now, in dynamic tests of headless services like REST API, how do you provide the tool with known good requests, login data, and things like these to get some actual coverage beyond just, you know, the index endpoint?
Yeah, we experimented with Swagger a bunch, OpenAPI type stuff to really be able to browse REST APIs. Here's the thing: the DAS tools, they aren't particularly useful for thin layer APIs. Like you'll have a JSON API with 4 endpoints, and it takes an API token to get in. What's really the attack surface there? I mean, if you use a modern framework with an ORM, you don't have any SQL injections. If you're not rendering any HTML, you don't have any sort of DOM attacks. At some point, the best security control that you have is to reduce the attack surface to a minimum, and moving to REST APIs that essentially are as bare bone as possible is a great way to reduce the attack surface. And what we found is that we don't really need to scan them anymore. We essentially fix the issues directly in the frameworks, and by using mature frameworks and enforcing, and making sure that developers adopt the controls in our checklists, and that's basically it. I can't remember the last time. I mean, we still have some old style websites that need things like CSP to prevent XSS, but on an API, I can't remember the last time we had like a typical web application type security problem. Right? It just don't pop up anymore. In fact, a bug bounty a few years ago was catching a lot of these standard OWASP top 10 type issues. And last year and so far this year, we almost don't have anything in the web bug bounty that really targets web applications. What we get is a lot of left behind infrastructure that hasn't been cleaned up properly, that an attacker just found and tells us, oh, I can take over this domain because you didn't deassociate it from CloudFront or something like this, but no SQL injection or nothing like this anymore. Mm-hmm. So the point is, I think, that it is much better and beneficial to invest into using mature frameworks and mature programming techniques than it is to heavily invest into scanning, for example.
Mm-hmm. Yeah, I read recently on Twitter, somebody said some vulnerabilities can only be found by asset inventory, and there's a lot of truth in that, I think. But when you do a dynamic testing and use OWASP ZAP, for example, for some services, how do you handle false positives? So if there's a false positive, you don't want that finding to pop up the next time you scan the application. Is there a way to handle that and to put this into a whitelist or something?
Yeah, we have configuration files that essentially get consumed by, so Simon could do a whole week of talks on the automation he built around ZAP. But essentially, ZAP has an extensive API, and the API, the ZAP scanner is instrumented by a bunch of Python scripts. And so the Python script would consume a configuration file and say, if this is this vulnerability on that endpoint, we already triaged it, so don't report it again, right? So we manage it this way. My experience is that we can't use full-blown application scanning in automation, really. We do it a little bit on specific application, but it's not the general statement because of the false positive. So you never want those to go straight to the developers, for example, because they need to be triaged. before you report them, because there's so many false positives. The baseline scan is better because it's more of a binary assessment of whether or not you have a control, and that control is not really up for discussion. And so those are easier to send straight to the devs. And in fact, we have automation that will create GitHub issues or Mozilla bugs as soon as some of those failures are found on our applications.
Mm-hmm. Okay, so I think that was it in terms of questions. Thank you very much again, Julien, for taking the time, for getting up early for us, and awesome talk, and awesome that you shared those experiences with us. Thank you very much.
Thank you for having me.
Switch over and take the screen sharing away from you, if that is okay. Just to tell you folks that there is another Life Academy talk tomorrow at the same time, 1 p.m. Central European time, about secure computing. And then the day after tomorrow, we're going to summarize all the SBA Life Academy talks. So that's 24, if I'm not mistaken. Just switch over to the next slide. Yes, 24 security talks, and Stefan and me are going to summarize all of them. There are some organizational security talks and some technical security talks. So if you missed some of the talks, make sure to tune in. And yeah, that's it for today. Thank you very much, everybody, for joining, and see you next time. Thanks, Julien, and have a great day.